We're going to look at the three different lot sizing approaches that we discussed earlier. So we'll work this problem out. So we have setup cost is 250. Inventory carrying cost is 90 cents per unit per week. Okay, so let's assume that this is item B and lead time is 1 week. Okay. So we have on hand, inventory and scheduled receipts. So we'll work this numbers like before. So we start with 100. So 100 plus 150 coming in minus 250, so 0. So now we have a requirement, so 200. Now since this is lot for lot, so we're going to order exactly that quantity. So we end up with these orders. The total cost here is total setup cost plus total carrying cost or holding cost. So number of setups, okay, just count the number of setups here. So 1, 2, 3, 4, 5, 6 is 6. So total setup cost is 6 times 250, and that is equal to 1500. Now total carrying cost is sum of the ending inventories, and I'm emphasizing this for a reason. Sum of the ending inventories times H. So note, ending inventories equal to projected on hand starting from week 2. So because the projected on hand is the beginning inventory, but what we want is the ending inventory. So we have to start from week 2. So that is equal to then 0 times 90 cents is 0. So total cost for lot is 1500 plus 0 is 1500. Now let's look at the next lot sizing problem, EOQ. Same numbers, but we're going to do an EOQ approach. So here we have to first find the EOQ. Okay, so given setup cost is 250, holding cost is 90 cents per unit per week. Okay, EOQ formula number is 2 times D times S over H. Now you can also, so here actually this D is per year, so holding cost is per year. But if we do this way, with D is average demand per week, then it will work. So what we have to do is to take the sum of the gross requirements and divide by the number of weeks. So D here is sum of gross requirements divided by number of weeks. So that is 250 plus 200, sum all the way till 400 and divided by 8 weeks. So that gives us 237.5. So that's D. Now we can plug that into this formula and we'll get EOQ. So 2 times 237.5 times 250 divided by 0.9. So this is per week and that is per week. Demand is per week, holding cost is also per week. So then it will work. So this is 363.2 and let's round it to 363. So this means every time we need to place an order, then we place an order for 363. So EOQ is 363. So we start computing here. 100, 0. So we have a net requirement of 200. In lot for lot we ordered 200, but now we're going to order 363. So 363 minus 200 will give you 163. And again we have a requirement of 37. So now once again don't order 37 but order 363. So 363 minus 37 will give you 326. Okay, 326 minus 250 will give you 76. So 76, 300 minus 76, 224 is the net requirement. Then you order 363 again. 363 minus the net requirement 224 will give you 139. Then 161 is the net requirement. So order 363. 363 minus 161 will give you 202. Then 202 will give you 198. So once again you order 363. Now we have to compute the cost for this approach. Now we can compute the EOQ cost on an annual basis and then convert it to weekly basis, or we can compute it for weekly basis and then we can multiply by 8 weeks. So total cost per week is ordering cost per week. This will be average ordering cost per week plus carrying cost per week. Okay. So if you take the average demand per week, so this is the average demand per week, D over Q, so that will give us on the average how many orders you have to place per week times S, and then Q over 2 times H per week will give you the per week carrying cost. So this is equal to 237.5 divided by 363 times 250 plus 363 over 2 times 0.9. That gives you 163.57 plus 163.35 equal to 326.92 per week. So total cost for 8 weeks, which is the horizon that we are working with, is 326.92 times 8. So that will give us 2615.36.